today we are going to see how we generated differential equations from the bond graph model. On the screen you have our simple example. It's bond graph model that we have explained already how to generate, and the task today is using this, how can we obtain the differential equations of the system. And also another objective is how do we simplify those equations in a form called the Cauchy form. Of course, we have different forms of expressing the differential equations. One is this Cauchy form, and the other one is the so-called state space form. So everything derives from the basic fundamental constitutive equations of each one of the elements and the connections that we have on the system. So let's see how we do those derivations. Okay, so let me, I'm going to disappear here, and we have as you can see in here, I wrote generate the bond graph model with power flow at the causal marks. This is what we have done right now. I think the next step that we're going to take is write each constitutive equation for each element and each connection. Very good. Let's try that. I'm going to use this in here on the right hand side to do this. What I'm saying is, let's just start, to make life easy, let's go in sequence. It doesn't matter where we start, really, in any order we want, but we just do it in sequence so we don't skip any bonds, Let's do this together, okay? What is E sub 1? What is E sub 1? E sub 1 is E sub 2. Yeah? And what is F sub 1? F sub 1 is F1, right? And this looks perhaps even too simple, but what is E sub 2? E sub 2, do you see what's happening here? E sub 2, according to this picture that we have, let me see. E sub 2, this one, is equal to E sub 3 right here. Yeah? And so because that's what caused the effort, that's what determines the effort. So this is E sub 3. And what is F sub 2? F sub 2, the one that determines what F sub 2 is F1. Very good. What is E sub 3? See, we are following this called E sub 3 is the result, E3 in this case is E sub is equal to E6 times E4, and so, but who determined what E3 is? E3 is determined by the summation of these two. So this is E sub 4 plus E sub 5. What is F sub 3? F sub 3 is going to be equal to f sub 3. Here is f6 minus f2. And we have e sub 4 is equal to 1 over c sub 4 times q sub 4. And then what's f sub 4 is equal to f sub 3 because of this. In f4 is caused by f3. But also dq sub 4 dt is equal to f sub 4. So that is the first differential equation is coming out of the C element in integral form. So if we continue, what's e sub 5? You see e sub 5 is f sub 5 times r sub 5, like this. And what is f sub 5 in here? f5 is f3. And what is e sub 6? E sub 6 is this one, is e8 minus e7. And what is f sub 6? F sub 6 is f7. Yeah. And then we continue. What is e sub 7? Yeah, e sub 7, what is the e7 is e sub 8 minus e sub 6. And what is f7? f7 is 1 over i7 times p sub 7. That's the constitutive law of the I element. And now we know that dp sub 7 dt is equal to e sub 7. We're not done, but this is generate the second differential equation. And then you have that e sub 8 is equal to SE8, and that equal to f, right? And that f sub 8 is equal to f sub 7. Well, so what I have done here is I have written the constitutive laws, the constitutive equations of the of each one of the elements. I have written the constitutive laws of each one of the elements, following the causal marks and following the power flow. You see E1 is equal to E sub 2, and F1 is F1. I think what I need to begin making emphasis is in here. You see, these are all the efforts are the same, but the one that determines the efforts for all the other one, the one that is the cause, is E sub 3. So that's why E6 is E3 and E2 is E3. Like in here, the flow F sub 3 is determined by the difference between these two, but that is what determines the flow for the one and makes the others to be like that. So this is the first task. This is the first. This is the steps. These are the two steps to find the equations. So in here, the equations of this system, the differential equations that you see are differential equations are this one, and you have this other one. Yeah, you have those two equations. But you see, still is a little mysterious here. How come a set of little equations, individual equations, represent the differential equations of the whole thing? So there has to be some way to reduce this a little bit. Okay, so we have the individual constitutive laws that we have used for each bond and so on, and for each element. There is a question in here what to do with this internal bond in here. Is E6 equal to E sub 3 or is equal to E8 minus E7? Both of them you could read from the bond graph. Both of them would be equivalent. However, we go with the bond that causes that effort. So E6 is caused by E sub 3. So we need to make a little correction in here in one equation to correct this one. And with that correction, we should be able to obtain the equations. This E sub 6 is equal to E sub 3. Very good. Now what I was going to say next is we have two expressions. So you could say we can put them in a form of simple expressions following the so you could say simplify. And you could say dq sub 4 dt is equal to f sub 4, and then you go to the list over here. What is f sub 4? Where is it? It's f sub 3, right? And what's f sub 3? F sub 3, take a look, is f6 minus f sub 2. F sub 6 minus f sub 2. Let's do this right so that we can read it really well. So f sub 6 minus f sub 2. And then what's f sub 6? Is f sub 7. And what's f sub 2? F sub 1. And then you have this is, and what is f7 is 1 over I7 p sub 7 minus SF1. So we have finished the first differential equation in a simplified form. This would be 1 over I sub 7 p sub 7 minus SF1. And this is going to be my first equation. Okay, simplified like this. I am going to do the same thing for the second one. And I am going to say, okay, let's see, we are going to change colors again so we can write it. And here you will have dp sub 7 dt is equal to f sub 7, and this is f7 is 1 over I sub 7 p sub 7. Interesting, it came out quite simple. In here, let's see, did we do this? No, we didn't. Excuse me, we have a mistake in here. It's not E7. This is E7, not F7. See here, this is equal to E sub 7 right from here. But E7 is E sub 8 minus E sub 6. And then you have, what is E sub 8 over here? we need to do you see what it, yeah, it's SE8, right? Yeah, this one is SE8 minus E sub 6, but you see E sub 6 is E sub 3, and then E sub 3 is E sub 4 plus E sub 5 plus E sub 8, sorry. We continue this with the E sub 4 is 1 over C sub 4 Q sub 4. What is E sub 5? E sub 5 is F5 times R5 okay, so let's continue over here. So we have 1 over C sub 4 Q sub 4 plus F5 is what? F5 is F3 times R sub 5 plus SE8. So you see everything is almost all done except F3. So let's just see what F3 is, so we don't have to repeat all this equation a lot. F sub 3 is F6 minus F2, and what is F sub 6? Is F7 minus F1, and F7 is 1 over I sub 7 P sub 7 minus SF1, right? Yeah, because F1 is SF1, yes, and F7 is 1 over I7 P sub 7. So if this is true, then we have that dP sub 7 dt is equal to 1 over C sub 4 Q sub 4 plus parenthesis 1 over I sub 7 P sub 7 minus SF1 multiplied by R5 plus SE8. So we could write finally one single expression, dP sub 7 dt 1 over C sub 4 Q sub 4 plus, you will say, R sub 5 over I sub 7 P sub 7 minus R sub 5 times SF1 plus SE8. You see, this is the second equation in here, and what you have in front of you, let me just put the number in here so that they would be easily recognizable. 1 and then 2. This set of equations constitute 1, you say, and 2. These are the Cauchy form. Okay, now this is the Cauchy form of the equations, but you see the in other words, Cauchy form of the equations are single expressions that are in terms of the inputs and the state variables. Okay, let me just put some labels to this to make life easier. See, this one is a state variable, and this is an input. So the Cauchy form, this is also a state variable. and so these are also state variables, and these are inputs. So the Cauchy form of the differential equations of any system are forms that are in terms of the state variables and the inputs. Here. So let's review a little bit this, and I just here we gotta see, and here you see we have a minus sign in here, and we need to make a small correction over here. Let's see, we're gonna put it here. This thing in here should be a minus sign, so that means this is minus, and this is also a minus over here, right? Yeah. And so if that's the case, we have a minus over here, and also a minus like this over here. This is okay. So when we go over here, we correct this, and we say this is a minus over here like this, and then we have minus,
I just kept it in the same order.
minus, then this is, let's see, let's do minus, and then this is going to become a plus, and then we have the correct equations. So we could verify these equations if we run the CAMG software, and we should be able to get the same thing. So